Okay, so this is Chapter 3, Review 1 in class exercise, and so now we're going to look at the answers for number 10 through 13. And so we have, we want to write an expression that evaluates each of the following situations. So is the value of first name 1 the same as the value for first name 2? So remember, when we compare strings, we have to use the equals or the equals ignore case. Now it says case sensitive. So equals means equals. It means as in terms of spelling and as far as case goes. So it must be capitalized or not capitalized depending on what this has in it. They have it a match is the idea. So is the value of first name, so you go variable dot equals. So it's always the variable that contains the string dot equals, and in the parentheses the argument is going to be could be the other variable that contains the string. So it's comparing the string that's in this variable and the string in this variable to see if they match. So maybe the first name is Tim in the first one and Bob in the second one. Well, those don't match, so that would be a false. All right, it might be Tim and Tim or Bob and Bob. Okay, then go on to the next one. Is volleyball the value of fave sport? So whatever the value of fave sport is, does it equal the string volleyball? So this is not necessarily in a memory location. So whenever you compare the value of a variable with a string, then that string has to be in quotes. So make sure that you have your quotation marks, because if you don't, then the compiler is going to think this is a variable call. All right, and so because it's not case sensitive, it doesn't matter if the user types a capital V or a lowercase v, then we want to say ignore the case. Just make sure the spelling's the same. So volleyball or capital V volleyball would be okay. Either one will work. All right, so that is number 10. And we move on. Number 11. What does the compiler do with each of the following lines of code? So num1 is assigned num2. If you just read it, then that makes it very easy that this assigns the value of num2 to num1. And the reason I ask this question here is because some students use accidentally, a lot of times, they'll accidentally use just a single equal sign in their Boolean expressions. This is not to be used in a Boolean expression. It's only for an assignment. And so the Boolean expression, of course, then is going to have equals equals, not just a single equal sign. All right, then let's see. B, num1. So what the compiler does is it looks at this expression and evaluates whether this is true or not. So it evaluates if num1 does equal num2. Double num3. This is from chapter 2. This is it reserves a storage location so it reserves a storage or memory location in the computer memory and names it num3. Those three elements are what you need in order to answer that question. Now we could add a fourth thing that says it reserves it as a double, because that affects how big the memory location or the storage location is. But this is something you need to know. When you see a declaration like this, then we illustrate that by drawing our little boxes here. Here's the memory location that's already in the computer memory, but it reserves one. In other words, when you make a reservation for a restaurant, they don't build the restaurant so that they can, have you come and sit there. The restaurant's already there. Just like you have a bunch of memory locations already in your computer memory. So double num3, the compiler goes and finds one of these already built and says, okay, I'm going to reserve this one for the variable or a memory location called num3. That's what it does. All right, this part is the same as C. It it takes one of the memory locations. Maybe it'll take this one over here. It'll name it num4, and then it will also store the 15 in it. So just the one additional thing is that it'll actually store value in it. Number 12. Okay, so okay, this one we want to indicate if it's going to yield the desired results based on a grading program, gradient scale. And if it doesn't, then you need to give an example and what the result will be to show that it doesn't work. And so if we look at the first one, A, just start with a number that's greater than or equal to 90. Okay, so if the score is 95, it will print an A. Well, that's good so far. But this is an if statement, and so this is another if statement. It has to be engaged. The compiler actually engages or checks the Boolean expression of every if statement. So this is one structure, an if structure, that is engaged. And this is another if structure that is engaged. So this is like the houses on a block. If you're going to go knock on all the doors of the house, of all houses on a block, then every time you see a house, you're going to go there. In this case, every if structure is like a house. The compiler is going to go to it and knock on the door and go, are you true or false? So it's going to go here, are you true or false? Well, 95 is greater than or equal to 80. So it's going to print a B also. Then it goes here because this is another house. Is 95 greater than or equal to 6? Well, yes, it is. So therefore it's going to print a C. So you see, this is why we talk about that you don't use a series of if structures if it's going to produce the wrong results. In this case, it's going to give you several answers. And it only can be one. It only makes sense that there's either an A, B, or a C, or an F. So we use if else if only one answer makes sense, only one alternative makes sense. If you go to this one, let's just take a 95 again. Now, is 95 greater than or equal to 0? Well, yes, it is. So it's going to print an F for 95. And then, of course, it's going to ignore the rest, remember. So you get a 95 on your test and you get an F? That doesn't make sense. Let's take a 95 again. Is 95 greater or less than 70? Nope. Is it less than 80? Nope. Is it less than 90? Nope. Then it must give an A, and that works. Okay, so but now you can't just try one number. You got to try other ones as well. Just because one number works doesn't mean all the rest are going to work. And so try 70. Is 70 less than 70? No. And so it ignores this. Is 70 less than 80? Yes. And so that means you get a grade of C and ignores the rest. Should 70 be a C? Yes, it should. So that works. And then you can try even more. Let's just take one more. Let's go 85. Is 85 less than 70? No. That's ignored. Is 85 less than 80? No. Is 85 less than 90? Yes. So it prints a B. Do we want 85 to print a B? And yes, we do. So this one does work if you were to test all the possibilities. So let's move down to this set. All right, so here we have, this one is actually correct. So if you were to test all the possibilities, you would find it would print the exact ones that you want. So let's go to E. Why is E false or not going to work? Well, if you were to take, let's say, a 95, like I was doing before, 95 is less than or equal to 100, and so it would print an A. So you're thinking, oh, well, this is good, because, of course, it's going to ignore the rest. And you're thinking, okay, well, this is going to work. I'll just go on to the next one. No, you've got to test all types of possibilities. So let's test something in the next section, like an 85. Well, is 85, which should print a B, is 85 less than or equal to 100? Well, yes, it is. Oh, it's going to print an A. It's going to ignore the rest. So an score of 85 prints an A. That's not going to work. So you know this is not going to work. Once you find one example that works, that doesn't work, then this thing is, you got to change it. Okay, let's check this one. Again, like I've been testing 95. Well, is 95 greater than 95? 90. Yes, it is. Well, that's great. So therefore, this must work because it prints an A. Let's try 85. Is 85 less than or greater than 90? No, so it ignores. Is 85 greater than 80? Well, yes, it is. So it prints a B. Wow, this is looking really good. But there's one thing that we haven't tested. We haven't tested the boundary numbers, and you've got to test the boundary. Remember I said that in our notes. We've got to test the boundaries. You've got to test your 90s, your 80s, your 70s, your boundaries. So let's check a 90. Well, is 90 greater than 90? Well, no, it's not. It's the same. It's not greater than. So it's going to ignore the A and print the B because 90 is greater than 80. All right? And that's not going to be good. I mean, if you were to have tested, let's say you test the 80. Well, is 80 greater than 90? Nope. That's good. Is 80 greater than 80? No, it's not. So this is ignored as well. And so 80 is greater than 70. It's going to give 80 a C. So maybe everything works, but the boundaries. So the boundaries, neither one of these boundaries are going to work. So that's why this one does not work. All right. Let's go to, the last one. Okay, this is something that we learned in Chapter 2, and we could very potentially have this same type of question on the Chapter 3 test. So if you're asked to get input from the user, you need to have a prompt. If you're going to use the scanner, you got to have a prompt so that the user knows that they are supposed to enter something and what they're supposed to enter. So the user types in the amount. So let's say spent on gas, $64.15. Well, you got to have something that reads that input. All right, it reads the input, and we say scan.next double because it's reading a decimal. And then we have to store it so we can use it. If you don't store it, if you don't have this part of the line of code, it will not store it, and therefore you can't use that 6415. So this 6415 is assigned to this variable, and we are including the data type because it hasn't been declared yet. Now, if you could have said double and gas cost, and I'll just go ... and declared the variable up there, and then not use the data type here, and then this would have been okay. All right, so that's getting input from the user, and that's it.